Hello, Dwani. How are you, Dwani?
I'm good, how are you?
What are they doing in school, ma?
So we just took our final unit test on Tuesday, and so until May 12th, we're just doing AP review. I mean, we do have a fourth unit, but they'll go over it after the AP exam because we're not tested on it. It's only on the final.
Yeah, I
Plus,
get
like,
it, ma.
if
But you
you,
know how less you're
yeah,
studying, than honors pre-calc.
yeah, and I like that we have more than a month of review set for us.
Oh yeah, yeah. See, I'll also give you three sample tests and stuff. No, three, illa, four sample tests and stuff. FRQ separately will review.
Yeah, cause like I'm gone like for almost 2 weeks in between, so like having this long review actually helps me not miss a lot
Oh
of
my
tests
goodness.
and stuff.
Okay.
So yeah.
Oh, okay. So, okay, for the Decava,
Yeah, for DECA, and then I'm also gone for BPA the week the next week, I guess.
oh,
Like
the
the week
business
after DECA.
competition, huh?
Yeah. So I missed a lot of school right before the AP exam. So
Oh my goodness.
yeah.
That's hard, ma.
Yeah. Didn't
Hmm.
expect to qualify, but I did. So
School you're going to miss, huh?
yeah, but the good thing is it's mostly like AP reviews, like because four of my classes are AP, so that helps.
You'll be fine, Madho.
Yeah.
You'll definitely be fine. Kuda? Yeah, yeah, please. The moody way poporo. Okay. So did you take the test on polar graphs?
Yeah, it was the polar, rectangular, and like rate of change on like those polar, like the polar graphs, like where they give you just a table. You have to find the rate of change of like the radians and whatnot.
Okay. Yeah, that's what I wanted to cover and finish the vector piece today. So let's see.
Yeah, we don't learn vector in school. We only learn it for the final exam,
Yeah, after
like
the
the
test,
semester
huh?
exam.
After the test.
Yeah.
Okay. Okay. Hi Lopa. Hi Advik. How are you? Okay, the rest of them they're going to be late as well. I don't know what is going on. Everybody is busy. Every one of your pre-cal kid is busy. That's what I'm seeing. There's no single week where everybody is in. Anyway, yeah, we'll see. I want to finish both. Let's see. Lopa, what are you doing in school, ma?
Or we have a test over like polar coordinates, polar like stuff, on Tuesday. So
Oh,
we're
then
just
that's good. Okay, so we'll finish whatever we are doing in polar, and then I'll also do vectors. I'll finish vectors. Okay, last week I think we had kept the calculator in radians, is what I feel, because whatever we said in class seemed right. So let's see that as well. Mana, what are you doing in school?
Love sines and cosines and vectors.
Okay, okay. I'll touch through that, but I really want to finish the polar graphs. Is that okay?
Yeah.
Okay. You're understanding polar graphs, right? Advik and Manav.
Yeah.
Oh, that's good. Okay. We will also finish the rate of change in polar graphs. Okay. So what did we do? 3 point. 1 second. Yeah, 14A. Okay. Do you remember the graphs for these? Let's see first. How about this? Do you remember the graph for 4 cos theta, 4 sin theta? Okay. Do you remember the graphs for 4 cos theta? F of theta will be equal to 4 cos theta. Do you remember the graph? Do you remember or no, guys? Based on that, I'll go ahead, guys.
Yeah, I remember.
Okay. So the graph is going to be like this. This is going to be 4, right?
Yeah.
Okay. So what is the cycle? What is the cycle in the sense the table of values? I want to give you the table of values. Hold on. Yeah, for the 4 cos theta itself I have the graph. So let's see. So the 4 cos theta is going to be this. What did I paste? What is going on? So basically what did I do? I have this function 4 cos theta. So theta is your x, f of theta is your y, right? This is your x, this is your y. It's like that, right? So for theta I took 0, pi by 6, pi by 4, pi by 3 and so on till 5 pi by 6 and pi. Now the corresponding values were 4, 3.464, then you had 2.828 and then minus 3.464 and then a minus 4. So what did we do here? For 0 we had a 4. So this was the first point. The second point was pi by 6 is 3 point something. Pi by 6 is somewhere here, right? Somewhere here, right? 3.6 and then pi by 4 is around here, exactly here, 2.8 something. It reduces further, 2.8 is here. And then what? And then 5 pi, okay, it goes on like that. And then for 5 pi by 6 and pi, for 5 pi by 6 is somewhere here, right? So for 5 pi by 6 it's my, what did I do? Yeah, for 5 pi by 6, right? It'll be like this, right? So when it ends, right, minus 3 points. So for 5 pi by 6 the angle is here, so minus means I'll put it in here and then it ends with a minus 4 for pi. Pi is a minus 4, so this side. So like that, if we plot the points, we'll get a graph like this. Suppose if it is minus 4 cos theta, what would happen to the graph? The graph switches sides, but the cycle is always 0 to pi. Any questions here? Similarly, for f of theta equal to 4 sin theta, what happens? The same graph goes up. This will be 4. Okay. Then the next one, f of, this is what we discussed already. F of theta will be equal to minus 4 sin theta. The graph goes down. Any questions? Okay, now let's go ahead. Now comes the harder part. Okay. Now let's work out a few. Okay, first let me show what is going on. 4 cos 3 theta. I really would like you to go to GeoGebra as well and try. Desmos calculator. Let me see which one shall we go for. Yeah, the link is taking you to a site outside of YouTube, correct? Go to the site. Okay. So guys, one way is to use the Desmos calculator, or what did you use, ma? GeoGebra website. What did you use, Dhwani, at school?
We just used Desmos, but we barely graphed them. We weren't supposed to graph them, so we kind of just looked at graphs.
Oh, you just looked at graphs, but it's better to understand how it came, right, ma?
Yeah, we did use Desmos, when they were explaining the different, the spiral, the petals and whatnot.
Okay,
Yeah.
okay. So that's also fine in a way. See, if you use Desmos, go to Desmos calculator, polar graphs, then let's go ahead and try a few. In the sense, what do I want you to do? Let's see. Yeah, we'll go ahead and do odd and sine, even and cosine. Now let's see. Okay, the next graph which we want to try is 4 cos 2 theta, 4 cos 3 theta. Okay, we are going to discuss rose graphs, rose petal graphs, rose petals. Okay, that's the type of graph. Now, what happened to 4 cos 2 theta? Here it is cos even. This is cos odd. See this theta, this number is what I'm meaning. Okay. Now let's say if it is cos 4 cos 3 theta, let's do that first. Oops. 4, I'm going to put cos 4 cos theta. So how am I going to draw the graph? Okay. What happened to the graph? Hold on. I'm comfortable with GeoGebra. I don't do it using this mouse, but that's okay. Let's see. Let's find out how to do. Okay, it's coming through. Good. Okay, now what I'm going to do, the slider, right? Start from 0. 4 cos. I really want to put 2 theta first. Or 3 theta first. Okay, one thing what you have to observe is if it is cos, right? If I move the slider, see what happens. From 0, I'm going 0. See what happens. It comes to the 0 point, and then see, it goes like this. See what happens. This becomes a rose. Do you see? Meaning the cycle is just pi. It's not even 2 pi, but it finishes off the full rose petal. You see? So in your case of 4 cos 3 theta, right? See, cos and odd means, suppose if this number is n, then n petals will be there. Fine. Any questions here? So it's any questions here? Any questions here? So it goes like this. So any cos graph, right, will be on this axis, polar axis. Any cos graph will have a petal on the polar axis. That is the way to differentiate cos and sine. Okay. Now let's say the same graph, we are going to try it for 4 cos 2 theta. See what happens. 4 cos 2 theta. I'm going to start from 0. Okay. I'm starting from 0. I move the graph, come to the 0 point. Again, see, cos graphs always are have a petal symmetric to the x-axis, polar axis. See, it goes till pi. 3.14 is pi, right? So let me wait there. What happens at 3.14? Do you see? Exactly at 3.14, it has not finished the petal. So I keep moving. See what happens at what it concludes. It concludes at 2 pi. So when you see that, here 4 cos 2 theta, right? So for this you will have 2n petals. Any questions? It will be symmetric. It will have a petal around the polar axis is always present for cos graphs. Any questions? This is the best way. If there is a symmetric petal about the polar axis, it is a cos graph. Okay. Cos odd value you get, then it is n number of petals. Cos even value you get, you will get 2n petals. Any questions? My mouse. Any questions on that? Any questions, ma? How did I get the graph? Advik, do you understand how we got the graph?
Yeah.
Cycle is 0 to pi for odd. Okay, for even the cycle is 2 pi.
Okay.
Now can I go ahead with sine? What happens to sine? Let's find out 3 sine phi theta. 3 sine phi theta. Let's try 3 sine phi theta. We'll try 3 sine or 3 theta, 3 sine, 3 theta. First the 3 sine we need, right? Let me go through this quickly. It will not take time. Sine. Let me try phi theta. See what happens. There is no petal that's symmetric about the x-axis. If there is no petal that's symmetric about the x-axis, it's sine. Okay. Now, the number of petals is an odd number. So, it will be directly written. Makes sense? But what is this 3 amplitude? That 3, if you think about it, right? See, this is 2. This is 2. So, this is 1, 2, this is 3. Do you see this circle is 3? So that determines the length of your petal. Any questions? This is 3 sine phi theta. Mano, are you following, Mano?
Yeah.
Okay, now let's suppose if I make it 3 sine 10 theta, what would happen? We'll draw this in Seema. I'm not comfortable without drawing. 3 sine phi theta, I'm going to first draw. We'll start from the beginning. What is the cycle? I want you to clearly understand that. We start here, 0. It starts there. It goes opposite, comes back. So we stop here. What happens? See, the cycle is pi. Whereas if I make it 10 theta, oh, I'm sorry. I meant to put 10 theta, or let's put 2 theta. Okay. See what happens. Do you see? At pi, it's only half done. So I need to complete the other two petals. So whenever it is even, the cycle is 0 to 2 pi. Here, this is sine 2 theta, right? What is the amplitude? Amplitude is this length, right? 3 sine 2 theta. So here you have 2n petals. Okay. Whereas if you have 3 sine 3 theta, if you have, then you have n petals. Okay. It is never symmetric. Sine graphs are never symmetric around the polar axis. Any questions? Okay, this is one side Desmos graphing calculator. Polar graphs you need to mention, or you can go to GeoGebra. I really like GeoGebra. Okay, this is the first or the first few times I'm doing Desmos. Any questions? Can I move on? Lopa, are you getting ma?
Yeah.
Okay, how about this? You're going to tell me 2 cos 7 theta. 2 cos 7 theta. Manav, do you want to try and tell how many graphs, what graph and stuff? You can tell circle opens on the right, left, top, bottom. That you can say, and the rose petals and maximum distance from pole and cycle. Okay. Yep, you have to tell me circle opens number of rose petals.
Circle length is okay,
Circle
circle
opens.
length is 7.
Circle length is this one, right?
Oh, sorry. The
Circle
circle length
length is 2.
2, and then it has, since it's odd, it has, I don't think it's it's a rose petal with like one in the top left, top right, and bottom
Yep,
right.
since it is cos, there will be something symmetric on the x-axis, right? Just give me 1 second. Really sorry, guys. Okay, so there will, if it is a cos graph, it will always, there will be one rose petal that will always be symmetric about the x-axis. So with that in place, right, 7 theta, number of rose petals will be what? What will be the number of rose petals? Oh, we can
7.
do that in here.
7.
Oh, yeah, what will be the 7 will be the number of rose petals. Suppose if it is, let's do that and see quickly. 2 cos 7 theta 2. Manav, have you started discussing this in school?
No, we haven't done this.
Okay. So let's see. See, there'll be 7 petals. One will always be symmetric to the x-axis. Whereas sine, what would happen? The cycle is always 0 to pi because it is odd. Lopa, you want to try? Lopa, see, 2 sine is there will not be any petal symmetric to the polar axis. That will be the biggest difference. Okay, now let's see. I'm going to stop screen share, but I'm going to show you graphs. You're going to find out what is the graph. Okay, let's see. How about this? What graph is this? Quickly, you're going to tell me. Okay. But I'm not able to. Yeah, this is better. So what is this graph? You're going to tell me what graph is this. Okay. So let me share the screen. You can quickly identify graphs. This is pretty easy if you get a hang of it. What is this graph? Quick, come on. You can send it in chat, guys. Shall we send it in chat?
Like we're at the equation?
Yeah, ma. It is going to become a little harder, guys, unless we are very thorough with this. Going up is hard.
Wait, Miss Priya,
Yeah, go ahead, ma.
how do you tell if it's a cosine or sine?
That's what I'm saying. If there is a rose petal symmetric about the polar axis, then it is cos. I'm saying
And then sine if it's not symmetric to
it is
anything.
nothing is symmetric. See, there is no petal like this, right?
Yeah.
Automatically, it is a sine graph. So, what is the amplitude? 4. Do you see? So, 4 sine. What theta is this? How many petals are there? 2, 4, 6, 8 petals. So 2 sine 4 theta because this is 2. You see?
Yeah.
Makes sense? Once you get a hang of it, it's easy. But the thing is, I really want you to get a hang of it before I move to limicons. Okay? So let's find out more. Let's see. How to push this? How about this? Quickly, if you can say, that helps a lot. Advik, are you able to do Advik? Lopa, I really would like to get answers, ma. Shri, have they started this at school?
No. I think we're gonna start it now. We just had a test over 3.12.
Okay.
So I think we're going into polar functions next.
Go ahead, ma. Mano, have you answered?
Yeah.
Okay. Shri, it is 3 petals, right, Shri? Petals also should be counted, right?
Oh, okay. Wait.
You know what, Manav and Advik, is there a petal like this? I don't see a petal symmetric about the polar axis at all, right? So it should be this amplitude 5 and it has to be a sine graph. Number of petals is odd, so it will be directly written.
Oh.
Make sense?
So I submitted my answer then.
If it's even, how would you do it?
If it is okay, I'll show you. Yep. If it is even, let's get one example. So whatever given, you should be able to identify. If the equation is given, you have to identify the number of petals. If the graph is given, you have to identify the 1 minute, 1 minute. Oh my gosh. Okay, that's good. Okay, how about this? See this one? What is this graph?
Cosine?
Yep, cosine. So amplitude says 5. But are the number of petals even or odd? Odd means you're going to write it directly. Even petals means you're going to divide by 2 and write it.
Okay.
So here it's going to be 5 cos. But I don't know. 1, 2, 3, 4, 5, 6, 7, 8. 4 theta. Make sense?
Why would it be cosine?
Yeah.
Why would it be cos?
Because it is symmetric. One of the petals is symmetric about the polar axis.
Oh, okay.
Okay. And let me go there. 5 sine 4 theta, right? I'll go to Desmos.
Miss Priya,
Yama?
is this the first teak in polar functions? Is it like it's like the first it's like 3 point what would it be?
What would it be? Good question you're asking. Let me see. This is 3.14b. 3.14b.
So what's 3.13?
3.13 is what we covered, right? 3.12 you have done, right? 3.13 is the polar coordinates. 3.14a is the basic, let me tell you, 3.14a is what? 3.14a is polar graph starting. 3.13 is also covers polar to rectangular, rectangular to polar, complex rectangular. conversions.
All right.
Okay, 3.14a is the basic polar. Suppose if you have a point in a polar graph, what are the four ways of indicating it? And then basic four n cos theta and n sin theta graphs deciding on the cycle. How did you get those graphs? Does it go up or down like that? 1,4b concentrates on even for that matter a cos n theta graphs. The petals are all in 3.14a. Make
Okay.
sense?
Yeah, thank you.
3.14b, it's a little complex polar graphs involving limacons, cardioids, and limacons and cardioids, and Archimedes spiral. So that is 3.14b. A lot of complicated graphs. Shragvi and Lopa, you're not answering. Do you get it, ma?
Yeah, I get it. I sent the answers for the last two questions.
Oh, yes, ma. Sorry, ma, Lopa. Yes, ma. Sorry, ma. I didn't. Yeah, thanks. How about this? Lopa, have they already done this in school, Lopa?
Yeah, we have a test over all this on Tuesday.
Okay, that's good. So, how about this? Are you able to do? Next Wednesday, I'll keep you posted if we have the class or not. Okay? Next Wednesday, I'm not in town, so I'll keep you posted if there is class or not.
Okay.
When is your AP exam?
I think it's the 12th.
Is that
Yeah,
12th?
the 12th in the morning.
May 12th, huh?
Yeah, May 12th.
Okay. Thank God. I thought it was. Okay, May 12th. Okay. And then we have planned for 2 classes, right? Okay. We'll do calc. Hey, and one more thing. Dhwani, what have you taken? Calc AB or Calc BC?
AB.
Calc AB. Lopa, what have you taken? Okay, you're into that IB math, right? Shragvi, what have you taken, ma?
I'm also an IB, so
Oh, it'll be. I see. Okay. And who else I wanted? Okay, let's see. Advik, what for you next semester? BC, right?
I take both.
Yeah, BC, but then BC will come in the second semester, right?
Yeah.
AB in the first semester, huh?
Yeah.
Oh, wow. Okay, each of you. Shri, how about you? What have you taken?
I took BC.
You took BC, okay. Okay, let's. What did I not share? Where did it go? Okay, what is this graph? Quick, ma. You can send it in chat, I think. That way I am happy understanding who understands what.
Miss Priya,
Yeah, I think you know, right, Dhwani, this one? No, I'll come to vectors
Yeah.
now. You'll be able to follow. Vectors, last week, I think we had the calculator in the degree radian mode.
Yeah, we did in the radian one.
See, we had incorrect answers last week, remember?
Yeah, we had differing answers.
So it's because today I worked it out before the class to make sure we are getting the right answers. Nothing was wrong, but I did change the degree, my internet calculator to degree. So that was the main thing, I think. Let's see. Shragvi, oh yeah, Shragvi, correct, ma. Shragvi, did they start this in school?
yeah.
Okay. How much did you cover? Limacons did you cover?
No, not yet.
Okay. Today we'll cover all of the graphs, okay? And also rate of change as well. How was rate of change, Dhwani? Was it easy?
First, it was a little confusing because they also introduced increasing, decreasing in terms of polar
Exactly.
and rectangular graphs. But then after a while, I think I finally understood. And then there was this new equation y minus y1 equals m times x minus x1. Yeah. So after a while, I did understand it.
Oh, nice. Okay. Good to know. Okay. Now we know.
I increased my score by 500 points.
a cos n theta Sine and theta, odd and even is what we have discussed. Can I move on?
Oh my gosh.
So,
We're in fourth.
good. You, 1 second. Okay, now let's see. Okay, sine cos is done. So let's see more. Okay. Okay. See, now I would really like you to, I'll give you the graph. The thing is, we did not understand how the graph came into picture, meaning we did not put the x and y values. We did not put the r and theta values, and then we did not understand what the graph, what was there in the graph, right? So without understanding that, this is going to be a little hard. Let's see. Okay. Now, let me go ahead and share the Desmos with you. This is going to be a little difficult since you have not, meaning we did not do the graph as is. You just saw what is in the graph, right? So that's going to be a little difficult. Let's see. Where is Desmos? Oh my god, what is this? Yeah, here. Okay, so now I'm going to take up a graph. Let's say 4 cos 3 theta. I will have 4 cos 3 theta. You know this graph. Very easily you know this graph. But the thing is, we did not know how we did this graph. Basically, we started with 0, substituted 0 degrees, let's say. We substituted that 0 degrees here. 4 sine 0. So 4 sine 0 was 0. 4 sine 0 was, sine 0 is 0. So 4 times 0 is 0. So r was 0, theta was 0. 0 comma 0. That was the point in the graph. And then what happened for pi by 6? So like that, suppose let's say we have this graph. Okay. In this graph, in the polar graph, I want you to tell me if I have the, okay, endpoints of pi by 6 to pi by 3, where is the graph? Endpoints of pi by 6 to pi by 3, meaning pi by 6 less than or equal to theta is less than or equal to pi by 3. Where is that graph? Do you see what I mean? Do you understand what I'm asking, guys? Do you understand what I'm asking? Meaning, here I'm going to 4 sine 3 times pi by 6. Where is it? Where is the point? That's what I'm asking. Meaning, which curve tells the graph between this and this? Similarly,
Could I draw on the screen?
Oh yeah, please.
Wait, is this the graph? It's this one?
Is that the graph? Okay. How do you say so?
Oh, no. It's from
4 sine 3 theta is what we were doing, right? 4 sine 3 theta. Did it do good? Yeah, 4 sine 3 theta is correct.
No,
Four.
it's meant to go like from here, not from.
What ma?
So this is
Pi by 6 to pi by 3, right?
It's just this line in between.
Ah, good. Pi by 6 to pi by 3. Yep. Pi by 6 to pi by 3. Comma 0. Minus 1 comma 0, right? Okay. Yep. So this will be the graph. Pi by, makes sense?
Yeah.
Yep. You need to be able to say with the endpoint. So how do you do it? You substitute theta equal to this. You can find the value of this. 4 sine, what is that? Pi by 2. This is 4 sine pi. So this would be 0, 0, right? So this would be 0. This would be 4 sine pi by 2 would be, this is for pi by 6, right? Yeah. So that would be 1, so 4. Makes sense? Shragvi, does it make sense?
Yeah.
Okay. Now let's go ahead and try. I really want you to try. Let's see. You're going to tell me. minus what did we do? Okay, yeah, this is different, right? Okay, 4 cos 3 theta, 4 cos 3 theta, meaning, oh, we were dealing with this, 4 cos 3 theta. Let me draw the graph. Okay, I'll show you the graph. 4 cos, oh, we wanted 4 cos 3 theta. Now tell me which part of the curve is that, meaning you can tell me. I'll mark it as 1, 2, 3, 4, 5, 6. Which part of the graph is 4 cos 3 theta in the interval pi by 6 to pi by 3? Pi by 6 to pi by 3. I'm asking for pi by 6 is less than or equal to theta is less than pi by 3. See, yeah, so you find out. See, pi by 6 is this, right? Pi by 6 is this, I'm sorry. Pi by 6 is that line. Pi by 3, did I place it correctly? I don't know. Pi by 6 is this line, guys. Pi by 6 is this line. Okay, pi by 6 is the second line. And pi by 3 is this line. So, which is that part of the graph? Which is that part of the graph now? Clearly, it is between this and this. Makes sense, guys? Advik, are we getting it?
Yeah.
Okay. So, if they give you endpoints, you should be able to identify which part of the graph is what we are discussing, that you should be able to identify. How about phi sin theta, pi by 2 to pi? Phi sin theta, pi by 2 to pi. Let's put 5 sin theta, pi by 2 to pi. Shall we try that? You can tell me in chat. Okay, I'm going to put down. First, I need to draw the graph and put the numbers. 5. I want to put 5 sin theta. Phi sin theta. I really want to understand pi by 2 to pi. Pi by 2 is this part of the graph. Pi is this part of the graph. So, which is that? So, the part of the graph, which one? This is the part of the graph. Any questions on that? Any questions on that? So, you should be able to find out the endpoint values. Given the endpoints, you should be able to find the endpoint values. Can I move on? Okay. Now, the next thing we are going to learn is, that's the hardest part of graphing, but once you understand, then it's going to be pretty easy. Okay, so let me share the notes page with you. Here, a plus or minus b cos theta graphs we are going to study now. Okay, till now we did we studied a cos n theta. N can be odd, n can be even. We studied a sin n theta. N can be odd, n can be even, right? We also did r is equal to 3 graphs, theta equal to pi by 3. R equal to 3 graph is what type of a graph is that? R equal to 3 graph is what type of a graph it is? Advik, you can tell me. In polar graphs, if you say r is equal to 3, how does the graph turn out?
It's like a circle around the origin.
Yep, it's a circle. This circle is r equal to 3. Advik, did you get it?
Yeah.
Okay, suppose if it is theta equal to pi by 3, what type of a graph is that? What type of a graph is that? Try, guys. Theta is pi by 3. Whatever be your r value, theta is pi by 3. So what would happen? It will be a?
It's a line.
Yeah, it's a line. Theta equal to pi by 3 line.
No, pi by 3, and then r equals 3 is a circle.
R equal to 3 is a circle, ma. Theta equal to pi by 3. Yeah, correct, ma. Now your understanding is correct. Theta equal to pi by 3 is a line. R equal to 3 is a circle. Now we'll go ahead and do R will be equal to a plus or minus b cos theta. In this case, right, guys, there are different scenarios. Okay, the first scenario we'll consider is A is equal to B. Okay, I'm going to put 3 plus 3 cos theta, or 3 plus 3 cos theta I'm going to have. So let me show you the graph directly. Okay, but one thing, after explaining that, I'll give you the graph. You should be able to find the equation very quickly. Okay, so remember this one. The first scenario that we are discussing is A equal to B, and it's pleasant to have A equal to B. That's how I remember that. Okay, so we are going to, from rose petals, we are going to turn ourselves into hearts. Okay, so that graph is called cardioid. Okay, what it is going to look like? The first scenario is very nice. A is always equal to B, meaning the two numbers are equal, so we get hearts. We like that, right? So it's a cardioid. So I'm going to share 3 plus 3 cos theta. We are going to do it and see now. Why is it so big? I don't know. Yeah, I think this is better. So 3 plus 3. Do you see it? Now, how does this work, guys? Let's discuss this, okay? 3 plus 3 sine theta. You know sine theta graphs already, okay? You would have drawn something like this. But this is 3 plus 3 sine theta, right? Now, let's do it. Let's use the slider, please. I want to do it from the first. Slider is here. See, it goes. First, what happens? See where it starts. It starts at a 3. You see? It starts at a 3 here. Do you see? And then see what happens. See the cycle as well. It finishes. Now, see, so the cycle is 0 to 2 pi here. Just like even petaled graph, the cycle is 0 to 2 pi. One another thing, when you observe how to find the amplitude here, see what is happening. This is 5, this is a 6. Please see the pattern and tell me how are you doing this. Okay. And when you think about it, see, this is a 3. This is a 3. What is the pattern here? Do you see any pattern with these numbers?
The bottom values are 3. And
correct. The exact numbers.
The
but then
values are 3, and then the top value would be 3 plus the
3. Yeah, exactly. Suppose, let's say I have, how do you think it would turn out? 3 plus 3 cos theta is this graph, right? Now, if I put the same graph as 3 minus 3 cos theta, what would be the change? Remember our graph, right? We did both actually. A cos n theta we did, minus A cos n theta we did. A sin n theta we did, minus A sin n theta we did. So now I'm changing this to a minus. So how would it appear? If the numbers are the same, it's a cardioid. But how would it appear?
It's just 3 units down and then...
Exactly. So if I change it to, let me erase all this. If I change it to negative, see how the graph changes. See? It gets reflected on the polar axis. Any questions? Now let's say I wanted cos graphs. So what do you think if I change it to cos? Shragvi, can you tell me how does this look? 3 plus 3 cos theta. Do you know how does that look, ma? Shragvi. It's okay. If you don't know, you can say you don't know. I'll explain. No problem at all. I'm just wanting to understand. That's all. You want to try or no?
Could you tell me?
Sure. Okay. So cos theta graph, meaning this has to be a 3. Remember, it will be symmetric about the polar axis. It's a cos graph, right? And it will be the sum as well. So one point will be here. But then When you draw, this is going to be a cardioid. This is going to be a heart. Okay, this is 3, this is 3. So up and down it will be a 3. 1, 2, 3. 1, 2, 3. So the cardioid graph will be like this. Does that make sense? Wait, did I? Yeah. Let's do it and see. 3 plus. So we need cos, right? So I'm going to bring the slider like this. Do you see it? Does it make sense? Shri, does it make sense? I don't even see you.
Yeah, I'm getting it. This is like the first time I'm seeing this, so yeah, I'm getting it.
Okay, how about Shragvi? Did you get it, ma?
Yeah.
Now, if I make this as minus, what would happen, ma, Shragvi? What do you think would happen? Manu, you can guess? Or Advik, you can guess?
If you change
Advik,
it
you
to
can.
minus,
Huh?
if you change it to minus or positive,
Yeah, I'm changing it to minus.
it moves to the right 3.
Yep, like this. 3 plus 3, 6 will be the amplitude here. This will be 3, this will be 3, and then they will be connected. Make sense?
Yeah, I thought it was like a normal function, like where if it's negative, it goes right.
It goes right means?
It's like if you move it horizontally, it will go right.
Oh, no. Okay. See, in any function transformation, if there is negative, what would happen, Manav? Remember?
Yeah, reflection.
Y equal to, so it is a reflection, right? So here it gets reflected on the theta axis. It gets reflected on the vertical axis. Can I move on?
Yeah.
Okay, now I'm going to share the notes page with you and then give you graphs. You're going to tell me what sort of graphs are there. Okay, let's do it quickly. Let's see. How about this? Guys, we are going to consider 3 scenarios today. It will be confusing. So unless we get a hold of this, things will be confusing. How about this? What graph is this? You can shout out now, one of you. Lopa, do you want to shout out? What graph is that? Shout out, Lopa. So it is a cardioid. So it is a plus b cos theta or sin theta. What graph is that? Amma, please, one of you, ma. Advik, you can?
I'm not sure.
You're not sure. Okay, no problem. So
It's a negative cosine graph.
yep, see, cosine graph comes like this. So it is reflected on the polar axis, right, and on the vertical axis, right? So definitely it's minus cos theta is there, but it should be a minus b cos theta. But what are a and b? Both are equal, right? Here it's a cardioid, it's a Harton. So first let me calculate what it is. 1, 2, 3, 4. Coffee set. 1, 2, 3, 4 means the added value is a 4. But here when you look at it, right? Where is it? Here. See, this is a 2, this is a 2. So what should be a and b? Make sense, guys? So this is a 4 means the added value of these two will be a 4. But how to find out each number? So this one here, 2, 2. It's like the eyes of the cardioid. Okay, let's go ahead and do one more. How about this? 4 minus. How about this? What is this graph, ma? You do it, guys. What graph is this? You're going to give me the, let's practice together, guys. I don't want to put anybody under the bus, but at the same time, please cooperate and answer. What is this graph? See, this is sine, this is minus sine, right? And then this is cos, this is minus cos. Okay, if it is circles, okay, cardioids means it is always of the format a plus b cos or sine theta. Okay, a is always equal to b if you have a Harton. Now, what is this? Guys, I want you to, one of you who has not dealt with in school, Lopa, do you know?
Wait, can you repeat the question?
Yes, ma. I just want, what graph is this?
Isn't it a cardioid?
Cardioid, ma. But what is the equation?
It's
The eyes are here. Huh?
1 second, sorry.
Yeah, no problem. I'll help you, I'm saying. 1, 2 on both sides. So what should be the value of A and B?
The A value would be 2.
2. But is it a cos graph or a sine graph or minus cos graph or minus sine graph or whatever?
A minus sine graph.
Yep. So 2 minus 2 sine theta. Makes sense? Does that make sense?
Yep.
Yep. When you look at it here, 1, 2, 3, 4. The added value is this amplitude, the distance. Can I move on? Okay. That is a cardioid. Okay. And the last one, let's see. How about this? How about this? I just want it to be a little bigger, guys. Oh my god. How about this? What graph is this? Advik, do you want to try?
Yeah.
Try. I'll help you. I'll also work with you. Try.
Okay. Is
1,
it
2, 3.
3 plus 3
This is
sine
6.
theta?
3 plus 3 sine theta. Correct. Suppose if the same graph appeared like this, right? What is that then? I'm sorry.
3
That would
minus
be, yeah,
3.
3 minus 3 sine theta. Yes. So we have only discussed one scenario where A is equal to B in A plus or minus B cos theta and A plus or minus B sine theta. This is what we have discussed. Only one scenario we discussed. That is the first scenario where we are going to get hearts, all hearts. The second scenario, what we are going to discuss is, we will have to discuss 3 scenarios, okay? The second scenario, but again, guys, I really want you to, before I go to the second scenario, right, I really want you to understand how this graph, this one is 1, 2, 3, 3 plus 3, 3 plus 3 sine theta, right? Okay, suppose if you draw it in a rectangular coordinate, right? The cycle is 2 pi, we already did it. We already found, okay? Now, let's see this one. Pi by 2, pi, 3 pi by 2, and then 2 pi, right? This is on a rectangular coordinate I'm graphing. This is the x-axis, this is the y-axis. How will the graph be for this one? Remember, 3. The graph moved up by 3. The graph moved up by 3 means usually the midline is here, right? Moved up by 3. So the midline is this, but the amplitude is 3. So what happens? 4, 5, 6, right? Now, sine graph, right? So it starts here, okay, because it starts at the midline, right? Now, at pi by 2, it goes up 3 steps. At pi, it comes to the midline. Again, 3 down, right? And then it goes here and stops. Do you see how this is graphed? Do you see the relationship between these two? Okay, suppose let's say we have 3 minus 3 sine theta. How you draw it in the rectangular coordinates? X y, again I am going to have 0, pi by 2, pi, 3 pi by 2, 2 pi, 3 minus 3 sin theta. So it moved down, the midline moved down by 3. You know what? This is not going to work like this. 3 minus 3 sin theta, right? So let's say pi by 2, pi, 3 pi by 2, and then 2 pi. Now the midline moved down, meaning midline moved down. See, the thing is, I'm sorry. No. So 3 minus 3 sin theta, right? So midline moved up or down here. This is a positive number. So it moved up or down. Moved up or moved down. This is a plus 3, right? Then it moved down. The midline moved up because it's a positive 3. Now the thing about this is, what is this then? Minus 3 sin theta. We know amplitude is 3. It's going to up 3, down 3 we have to show because of this amplitude. However, if it was a plus 3 sin theta, we would have done things like this. One second, guys. So 0, it has to come like this, right? And then it has to go. If it was a plus curve, but now I have a negative one, so it is just a reflection. It goes like this. Did you get it, guys? Am I making sense? How do you graph this? 5 plus 2 sin theta. In a rectangular coordinate, how do you graph this? We are going to do pi by 2, pi, 3 pi by 2, 2 pi. What happens? Did the graph move up or down? Midline moved up or down? Anyone, ma? Midline moved up or down? Shri, you want to say?
No, I want to see how this is done first.
But we already discussed this, right? Advik, will you be able to say midline moved up or down? Depends on this, right?
Up.
Up. So it moved up 5. So that becomes your midline. Now, if that is your midline, right, what is the amplitude? Go up 2, down 2. However, it is not a reflected graph. So it starts at 0, goes to its maximum amplitude at pi by 2 and crosses the midline at pi. Then you get to 2 down at 3 pi by 2 and at 2 pi it reaches again the 0. So the graph goes like this. Any questions?
Oh, that makes sense.
Okay, so basically when you look from your x-axis, this is 7. This will be your midline and the lowest point will be 2. Make sense? Okay, now let's go ahead and try. So you should be able to plot the rectangular as well as the polar graphs for a plus or minus b cos sin theta. Now what did we cover? A plus or minus b cos theta and a plus or minus b sin theta, right? In this, what we covered, the scenario 1 was a equal to b. This produced cardioid graphs, hearts, right? Second scenario is, I'm going to consider, which scenario shall we consider second? We'll consider a greater than b probably. Yeah, a greater than b, 5 plus 3 cos theta. Now, 5 plus 3 cos theta. The scenario is a greater than b. If you follow along, it will be so easy in school. 5 plus 3 cos theta. Now the thing is, a is greater than b, right? We need to show this graph, 5 plus 3 cos theta. First, I am going to show it in the rectangular coordinate. How do you put it in the rectangular coordinate? 5 plus 3 cos theta. The midline moved up or down? Shri, you tell me now. Midline moved up or down?
Up.
Up by 5. 1, 2, 3, 4, 5. Midline moved up by 5. So that became your midline. 3 is your amplitude. So up 3, down 3. But again, the cos always starts at the maximum, then at pi by 2, pi, 3 pi by 2, 2 pi. What happens to the graphs? It starts at the maximum usually, right? And it goes down, right? And then here it reaches the midline at pi by 2 and 3 pi by 2. Lowest is, you need to see, lowest is it moved up 3 and down 3, right? 1, 2, 3. So this should be your lowest. Okay, now the graph will be like this. Does that make sense? Does it make sense? It comes back to the same point at 2 pi. So the cycle is 0, 2 pi. Okay, but how are we going to draw this graph? No, sorry. 5 plus 3 cos theta, right? So let me show you the graph. I really want you to see the ismos. Only when you once or twice see, you'll remember. 5 plus 3 cos theta is a complicated graph. I'm going to show it to you in Desmos. Let's see. So here, what are we going to do? We said A is greater than B. 5 plus 3 cos theta. See. 5 plus 3 cos theta. In this case, what happened, do you see? This is called a limacon. Limacon or limacon. What do they say in school, Madhwani?
They call it a limacon, but they
Limacon.
yeah.
Okay, I'll go with that. Limacon. Limacon, if A is equal to B, the limacon graph becomes a cardioid. It's a heart. Okay, but if A greater than B, then it becomes a dimple. It looks like a dimple, right? Dimple limacon. A less than B, that we'll consider later. Okay, it becomes a dimple limacon. But here again, guys, it's very easy. 5 plus 3, that is this, that is this amplitude. From 0, this is 8. This length is 5 plus 3. Okay, whatever be the number, 5 plus 3, that's all. Meaning, even if it is a minus in there, the length is going to be across from 0, it's going to go till 8. Okay, even if it is a negative. Only difference when it is negative is the limacon. What will happen here? 5 plus 3 is this distance. Okay, when you look at this distance, right, it is 5 minus 3. The difference of the two numbers is this. That is where the dimple comes. Okay, now suppose if it is a 5 minus 3 cos theta limacon, 5 minus 3 cos theta, what will happen? No change. Okay, meaning excluding the fact that it just gets reflected as a result. This is 2, right? The dimple happens here. The dimple happens here, but it'll go till here. So basically, it'll be like this. It'll be like this, limacon. Make sense? Does it make sense? Advik, are we getting or no?
Yeah.
Okay, now think about the graph for 5 or 4 minus 2 sine theta. How will the graph be? 4 minus 2 sine theta. How will the graph be? In a rectangular coordinate, first let's draw. Okay, so I'll start with pi by 2. Always pi by 2, pi, 3 pi by 2 and 2 pi, right? Now, sincerely the graph moved up by 4, so it is in here, right? This is the midline. Plus 2 up and minus 2 down. 2 up, 2 down. That's the criteria. Okay, if it is a sine graph, first I'll draw for a sine graph. Sine graph starts at 0, goes to the maximum, 2 more, right? Goes to the maximum at pi by 2, comes back to the midline here, and then 3 pi by 2 is your minimum, 2 down, and then 2 pi is again your 0. Okay. Now, what happens? This is your sine graph, but there is a minus 2 sine theta. So, I cannot do this, okay? This were the points for my sine theta graph. So, I'll put it as a, like this, okay? But actual graph is what? This is a reflection on the midline. So this graph would really become like this. Make sense? Because of the minus in here. Manav, are you following, Manav?
Yeah.
Okay, let's try this one. Okay, now 4 minus 2 sine theta, right? This is on the rectangular coordinate. Okay, now the same graph, how will the dimpled limison be? 4 minus 2 sine theta. How will the limison be? Limison, basically this has to be like this sign means, but minus sign means it has to be like this. So that gives you everything. 4 minus 2 sine theta. It is a dimple limison. So what happens? 6 here I have to count. 1, 2, 3, 4, 5, 6. Okay. It will go till there. But the dimple has to happen on the other side too, because 4, the number 4, the number 2. Subtract that, the dimple has to happen there. Make sense? So it will be a dimple limison in the sense it's going to be like this. I have drawn a heart in. I'll show it you here. 4 minus 2 sine theta. 4 minus 2 sine theta, right? Does that make sense, guy? 4 minus 2 sine theta. Does that make sense? Manav and Advik, did you get it?
Yeah.
Yeah.
How about you, Shragvi?
Yeah.
So, what did we discuss? When A was equal to B, it was a cardioid. When A was greater than B, it will always be a dimple limison. Cardioid, you'll have to add the two numbers to get one part of it. The eyes will be exactly at the number A, B. Here, A is greater than B, you have to subtract to find the dimpled place. You have to add to find the other side of the bulge. Can I move on? If it is negative, it is a reflection on the polar axis. Can I move on? Okay. Before I get going, right, I really want you to identify. The last one we need to discuss, okay? Let it take time. But I really want you to tell me what are these graphs. What is this graph? What is this graph, guys? You can tell me what is this graph. You can send it to me in chat.
Hey, Miss Priya, could you make the image a bit bigger?
Image a bit bigger. Okay, wait. I'll do anything, yeah. 3 minus... image a little bigger. How to make it bigger? I don't know. Oh, that is making it smaller. Okay, I got it. Okay. How about this? Is this better, Manav?
Yeah.
Okay. Can you all answer in chat, please? You don't keep quiet. If you didn't get it, I didn't get it. Simple. Manav, first of all, this is not a cardioid. This is a dimple, right?
No, I didn't answer the question yet.
Oh, sorry, Manav. The previous answer I mistook.
No, it's fine.
Oh, nice try. Yeah, minus is correct. Sin theta is correct, Advik. Okay, but let me see. Oh, is it 6? It is at 5, right? See, this distance is at 5 So, the added value of that should become 5. The dimple happens at 1. So, the number difference should be this. The number sum should be this. Am I making sense?
Okay.
A plus B will be equal to 5. A minus B will be equal to 1. So, what is that?
So it's 6 minus sine theta.
3. No.
Wait.
Seema, A plus B is 5, A minus B is 1 means what is 2A will be equal to 6, right? It will get cancelled if you add.
Okay.
So A will be equal to 3, right? So can I say this as 3? When I subtract the 2, yeah, when I subtract the two numbers, it becomes what? 1. So one number is 3, the other number is automatically 2, right? Does it make sense?
Yeah, kind of. Okay.
Kind of. Okay. How about Shri, um, Shragvi? How about you both, ma?
I sent you my answer.
You got it? Okay.
Yeah.
Ma, is there Lopa? Did you get it?
Yeah, I thought I sent it in the chat.
Dhwani? Dhwani?
Yeah.
Is it 2 minus or 3 minus?
I thought it was 2 minus 3 just because like that red point is at 3.
I'll tell you the problem with your thing. We are discussing the second scenario of A greater than B.
Yeah.
You have given me the graph for, you see
Never
what I
mind, I
mean?
gave you a cardion.
Yeah. You did the, no. You did this.
Yeah, which
Cardioid is A equal
wait,
to B.
sorry, I gave you the loop.
Inner loop limicon, yeah.
Yeah.
You are
Okay.
doing the inner loop limicon.
Yeah. Okay.
Okay, we have only discussed cardioid, which is a heartin. The second one is a dimple. You see the dimple? That's a dimple limicon.
Yeah.
Remember the order which we covered, okay? You'll never forget. A is greater than B, dimple limicon. Then A less than B is the inner loop limicon. That we'll see later, okay? Now let's see this one. It becomes harder, guys. Okay. The next one, with that we are done with the complex part. So how about this? How about this? Okay, how about this? Try this one. It's not a hard one, just that you need to get a hang of it. How about this? It is a dimple limicon. It is a dimple limicon. See, because it's not a cardioid, it doesn't meet at 0. So it is not a cardioid. So what is that? A plus B is what? I don't know. What is A plus B? 5 is this, means what is this? 5. This is 5, 6, 7, 8, 9, 10, 11. Oh, this is 11. So this one is, oh, what is this? This one is 1. What do you think? First of all, what graph is this? Sine or cos or minus sine or minus cos? It should be of this format. Okay, but what is this graph? A plus B sine or cos?
Positive sign.
Positive sign, yeah, correct. So plus sign is always there, right? Now the thing is, we have to fill in the A and B. This is A minus B. This is A plus B. Clearly, please, if you write the equation, you will get it. What is the answer now? What is A? Add both the equation, add both the equation. What is A? Guys, what is A, guys?
6.
Yeah, A equal to
A
6.
is 6 and B is 5.
B is 5, yeah, that's all. You got it? So A is greater than B, limicon works. Makes sense? So this is how you plot it. Last scenario I'll tell and then we can discuss it. Okay, now the last scenario is we considered A is equal to B. Everything, all are categorized as limicons, okay? A equal to B, that becomes a cardioid, okay? That is type 1. Type 2, A greater than B, it will be a dimple limicon. Okay? However your school calls, you call, okay? Now A less than B, that becomes, we call it inner loop limicon. Okay, what is this inner loop limicon? What I am meaning is 1 minus 3 cos theta, 1 plus 4 cos theta, 1 minus 2 sin theta, or 2 minus 4 cos theta. These are all inner loop limicons. Why? A is less than B. Okay. Suppose cos theta is just reflected here. So it should be like inner loop limicon means it's going to be like this. Let me show you. I'm going to show you 1 minus 3 cos theta. Let's try to find out more and do once and then you can leave. more practice is required, guys. Otherwise, this becomes extremely difficult as we move up if you don't understand. How about this? Okay, I have it. Now, we are going to discuss inner loop limison. So, first let's do 1 plus graphs we'll do. Okay, we don't want to confuse. 1 plus 3. See what happens? I'm going to make it bigger, guys. Okay. So, see what happens? 1 plus 3 is what we did. When you look at this, right? 1 plus 3 cos theta we did. Did we do 3 sin theta? What did we do, guys? I don't know how to make it bigger or smaller. 1 plus 3 sin theta, correct. So, the graph. See, let's look at the graph closely. We did sin theta. That you got it already, right? A plus B sin theta we know. Okay, but there is an inner loop, right? That itself tells A should be less than B. But how do you find it? What is this? 1, 2, 3, 4. So, A plus B is 4. 1, 2. A minus B is 2. So, what happens when you all add all together? A will be equal to 3. 1 second, guys. What did I do? Okay. Okay. Here the thing is, one of the numbers is 3. So basically, one of the numbers is 3. What is the other number? 1, 2. The other number is, see, A minus B is 2, right? If that is the case, the other number is 1. 1 and 3 are the numbers. Remember, A is less than B. So, you put 1 in here, 3 in here. Makes sense? This is the easiest way to get a hang of these graphs. When it is an inner loop limison, just find out what are the added value and the subtracted value. Have those numbers 4 and 2. Then, don't take it as A and B literally, okay? Because I put 2A. It should be B. It should be A plus B and B minus A. So I don't want to confuse you like that. Just have the sum as this distance, difference as this distance. With that, you find one of the numbers, and the other number it's very easy to find if you substitute. So you found out 2 numbers. Now, if it is an inner loop limison, A is less than B. Remember that and write down. Okay. How about this? Let me ask you this one graph and let you go. Okay. How about this? With that, okay, now rate of change we'll do next week. Okay, now let me ask you this. How about this? How to okay, I'll have to move this. What is this graph? You're going to try this one more question and then we'll disperse. How about this? What graph is that? The one you need to know the distance, right? What is that? 5, 6, 7, 8, 9. Okay, the sum is 9. This distance is 9. Okay, guys, tell me. What graph is this? First of all, what graph? Let's discuss. Is it cos or sine graph?
It is negative sine graph.
Sine graph. Up or down, it's sine graph, right? Now, how do I determine A and B? Plus or minus is this one. This will be a minus sine graph, right? Because it is a reflection. How do you determine A and B numbers? It is an inner loop limison. So, definitely A is less than B. How do you find out A? A plus B is a 9. But the other number, what is this? 1, 2, 3. A minus B is a 6. So, what number can I pick up? 1 is the added value. 2A will be, did I make mistake? 1, 2, 3. A minus B is 3, right, man? A minus B is 3. So, what happens now? One of the numbers is 6. The other number is
3.
Yep. As we said, A is less than B. So 3 has to be substituted here. 6 has to be substituted here. So the graph is 3 minus 6 sine theta. Did you get it, guys? Mana, were you following?
Yeah, I think I may have got the
Gist of
one
it? Okay.
one of the equations wrong.
Okay. Last one, ma. Okay, just finish this and let's go. 2. Please, I would like everybody to get it correctly. If possible, it's okay if you don't get it correct. First decide cos graph, sine graph, then decide negative, positive, then find out the numbers. Added value, subtracted value, then you get the graph very easily equation. How about this? This is the last one though. If you get it right, we'll leave. Next week, I'll tell you if there is class or not, probably. Did you get it? Oh wow, very nice, Mana. Very nice, Advik. You can leave. Did you get it, Advik? Very nice, Manu.
Yeah.
Lopa, yeah, you can leave. Manav and Advik. Next week, I'll tell you if there is class or not. We will discuss rate of change of polar graphs and finish vectors next week. Okay?
Okay. Thank you.
Yep. Bye
Thank
bye.
you.
Okay, now, Lopa, just one small change, okay? The added value, the added value is 7. Did you see that? Are you getting 7?
Okay.
The subtracted value is 3. So just write it down, you'll not make a mistake. A minus B is 3. So now 2A will be equal to
10.
Miss Priya,
10. Yeah. Yeah. You want me to check? Wait, Shri. Please don't be in a hurry. It's not, see, added value is 7, subtracted value is 3. Then what happens? 10 is 2 times the number, right? 2 times A will be equal to 10. So A will be equal to 5, right? If A is 5, B is 2, right? Does that make sense or not? Hey, Shragvi, you got it almost right. Here, definitely, it is an inner loop lemmason. So what happens? A is less than B, remember? So first of all, what we need to decide? First, we need to say the graph. This one is cos theta. This is minus cos theta, right? But I need to decide the number A and B, okay? A is less than, we know the numbers are 5 and 2. So how do you plug in?
Miss Priya, is my answer correct?
Yeah, I'm checking. Yeah, 2 minus 5 cos theta is correct.
Bye, Miss Priya.
Bye, ma. 2 minus 5 cos theta. Shri, Shragvi, Lopa, did you get it, ma?
yeah, I got it.
Yeah, I understood.
Okay, ma. I'll stop here, guys.
Thank
See
you.
you all next week. Bye-bye.
See you next week.
Thank you.
Bye, guys.